Welcome back to the deep dive. If you've been following the world of AI, well, this past week must have felt like a constant stream of pretty significant model announcements,
Oh, absolutely,
each
yeah.
one pushing boundaries in surprising ways. It's been an absolute whirlwind.
It truly has. I mean, any one of these developments would typically be a standalone headline story,
Right.
but to have them all drop in such rapid succession, it really points to an unprecedented acceleration in AI innovation. It's quite a remarkable time.
Definitely. So for this deep dive, we're going to try and cut through that noise and unpack the three major AI announcements that really captivated the tech world this week.
Okay.
We're talking about OpenAI's new GPT-OSS open weight models, Anthropic's Claude 4.1 Opus, and Google DeepMind's Genie 3.
The big three from the week.
Exactly. Our mission here is to extract the most important nuggets of knowledge, the key insights from these releases, just giving you the clearest digest of what happened and maybe more importantly, why it matters.
Sounds good. Let's do it.
Let's get right into it. Okay, let's kick things off with a development that many are hailing as, well, a major win for the open source community.
Hmm.
OpenAI's release of their first genuinely open weight models since, GPT-2, we're specifically looking at the GPTOS 120B and GPCAS 20B models.
That's right.
Now, for an organization often seen as, leaning towards proprietary closed models, what's the true significance of this move? What's the big deal?
Well, the open weight aspect under the Apache 2.0 license, that's really the headline here.
Okay, Apache 2.0.
Yeah, and this isn't just like a research release. It's a highly permissive license.
Mm-hmm.
What that means for you, the listener, is that these models aren't just available for broad research. Crucially, they're available for commercial deployment
Ah, commercial too.
and extensive customization, all without those really restrictive clauses you sometimes see. It signifies, I think, a profound, almost philosophical shift for OpenAI, maybe signaling a potential new direction towards, empowering individuals and fostering a more democratic AI ecosystem.
Yeah.
It's definitely a strategic pivot that's gotten a lot of attention.
Right. And when we talk about power, what can these models actually do? How do they stack up against, say, OpenAI's own existing closed models?
They're surprisingly capable, actually. The GPTOS 120B version, the big one, is reported to have reasoning capabilities comparable to OpenAI's own O4 Mini.
Okay. O4 mini level.
Yeah, while the 20D version performs similarly to O3 Mini.
Mm-hmm.
And just to give you some context, O4 Mini and O3 Mini are, highly optimized versions of their latest and previous gen models. They're known for pretty impressive performance in their class.
Right.
But what makes these new open weight models particularly exciting for you, listening at home maybe, is their accessibility.
How accessible are we talking?
Well, the 120B model can actually run locally on high-end laptops, assuming you've got about a 60 GB GPU.
Which is still hefty, but doable for some.
Exactly. And the 20B version. That can run on systems with as little as 16 GB of VRAM or unified memory. So that includes, the popular Apple Silicon Mac.
Wow, okay.
We've actually seen reports of the 20B model hitting around 30 tokens per second on a MacBook Pro M3 Pro with 18 GB RAM.
30 tokens per second, that's usable speed.
It is. And it's substantially faster than some comparable open models out there, like Google's Gemma 3. It offers a truly responsive local experience.
That's remarkable, running what's essentially an O3 level model on your own device, delivering that kind of speed. How have they managed to achieve that, especially with, such a large parameter count for the 120B model? It sounds a bit like magic.
It's not magic, but it's definitely smart engineering. And used a mixture of experts architecture, MOE.
Ah, MOE.
Hey, think of it like having a team of specialists, right? The 120B model actually has 117 billion total parameters, which sounds enormous.
It does.
But during inference, that is,
Yeah.
when it's actually processing your request, only a smaller subset, about 5.1 billion parameters, are active.
I see. So it's not using the whole thing at once.
Exactly. And the 20B model is similar. 21 billion total, but only about 3.6 billion active. This design gives it a massive overall capacity without incurring the full computational cost of running all those parameters simultaneously. Makes them much more efficient for deployment.
Clever.
And they've also debuted a new Harmony chat format that's also open sourced, and it includes some novel concepts like message channels, which could allow for more structured and complex interactions down the line.
So it's not just about the raw power then, but also smart design and maybe new ways to interact that could evolve how we use these models. What's the general buzz been like in the community since this, pretty unexpected release.
Oh, the buzz has been huge. The model's basically shot straight up to become the #1 trending model on Hugging Face.
Wow. Number one.
Yeah, which is, a key hub for AI model sharing and development. And there's been immediate, rapid ecosystem support,
Yeah.
integrations from major frameworks and platforms like VLLM, Llama.
Llama's great for running local models easily.
Exactly. And Grok for that super high-speed inference. And even day one support in llama.cpp, which is like foundational for running LLMs efficiently on consumer hardware.
Day one support is
It
fast.
is. And many in the community are expressing genuine surprise at the quality. There's a strong undercurrent of speculation, too, saying, if OpenAI is releasing models this good openly,
Then what are they keeping behind closed doors?
precisely, their upcoming GPT-5 must be truly groundbreaking, or insane, as some put it. It's definitely raised expectations to an unprecedented level.
That's fascinating, this blend of excitement and, yeah, intense speculation. But like with any big release, there's always a flip side, right? Have there been any criticisms or concerns bubbling up about these new models?
Yes, absolutely. It's not all roses. While they do perform impressively on some specific reasoning benchmarks, like GPQA, which tests complex multi-step reasoning,
Okay.
some reports indicate what users are kind of bluntly calling a hallucination fiesta.
Yeah.
And apparently, poor performance on simpler, more straightforward problems. So they can be brilliant one moment and then surprisingly off the mark the next.
Inconsistent then.
Potentially, yeah. And a really significant point of discussion is their heavy censorship. Many users are describing them as safety maxed.
Safety maxed.
Yeah, to the point of being, let's say, constrained or even hobbled. And this isn't just an opinion. In practice, it means the models might refuse to answer seemingly innocuous queries or just give overly generic, unhelpful responses because the safety guardrails are so strict.
Okay, so that could limit usability.
Definitely. And there's also a technical concern being raised, making such heavily censored open models widely available. Well, it could inadvertently help researchers or even malicious actors develop more effective jailbreaks
How so?
because they provide a testbed. These techniques designed to circumvent safety features, once developed on the open model, might then be applied to the closed proprietary models that companies rely on.
Ah, I see. So if I'm understanding this correctly, it's kind of a strategic paradox. OpenAI makes powerful models accessible, which is great for openness,
Right.
but their strict safety measures are maybe a double-edged sword, both for the user experience and potentially for the broader AI security landscape. What's the core takeaway for our listener here?
Yeah, that's a good way to put it. For you, the listener, this really translates into a fascinating strategic dilemma and practically a trade-off.
Okay.
OpenAI, traditionally the closed model company, is now offering these powerful open-weight options you can run yourself. But the heavy censorship means you're trading off some raw utility, some flexibility for that local control and accessibility.
Makes sense.
And the deeper insight here maybe isn't just the models themselves, but what this whole move signifies for OpenAI's long-term strategy.
Mm.
Are they truly embracing open source? Or is this more of a calculated move to set a kind of safe standard for open models, potentially shaping the whole ecosystem in their favor, while their own proprietary models remain truly unrestricted and, well, more powerful?
That's a really interesting question.
It's a key tension in the open source community right now, and it's something you'll undoubtedly encounter as these models get used more widely.
Okay, so from that massive open source release that's sparking all this debate about strategic shifts, let's pivot now to a highly specialized powerhouse model. Let's talk about Anthropic's Claude 4.1 Opus.
Right, Opus.
This was also pretty anticipated and maybe unintentionally leaked. What's this model bringing to the table, and who is it really designed for?
Claude 4.1 Opus is definitely a significant upgrade from its predecessor, Claude 4. It seems to have a laser focus on agentic tasks, real-world coding, and advanced reasoning.
Agentic tasks and coding.
Yeah, and it's quickly being hailed by many people as, quote, the best coding model in the world, for now.
For now is definitely the important caveat in this field.
Absolutely. And that description tells you its primary audience. Definitely developers, researchers, and professionals who are dealing with complex, multi-step problems, especially involving code.
So what makes it so incredibly good for coding and these complex agentic workflows you mentioned?
Well, its performance is reportedly exceptional. It leads the SWE Bench coding benchmark.
SWE Bench.
Yeah, that evaluates a model's ability to fix actual real-world bugs found in open source projects. Very practical.
Okay, that's impressive.
And it apparently absolutely dominates terminal agent benchmarks, securing something like 9 out of the top 10 spots on some leaderboards.
Terminal agent benchmarks. So using a command line like a developer would.
Exactly. Testing its capability to navigate and interact with a command line interface to solve problems. And its core strength seems to lie in what's being called superior tool usage.
Superior tool
Ending
usage.
is incredibly adept at leveraging external APIs, libraries, other digital tools to complete tasks. This is really critical for complex coding and these autonomous agentic workflows, where a model needs to do more than just generate text. It needs to execute, adapt, iterate.
Got it.
And it saw immediate integration, too, into popular developer tools like Cursor, that AI-first code editor.
Right.
And it's readily available on platforms like OpenRouter, which aggregates access to various models so developers could try it out quickly.
So it sounds like a true powerhouse for professional developers, really designed to tackle the most demanding real-world coding challenges. But are there limitations? Any ongoing community discussions or criticisms around Claude 4.1 Opus?
Yeah, there are always nuances, aren't there? Despite its strengths, reports say it still fails many spatial tests.
Spatial tests, like understanding diagrams or layout.
Exactly. Tasks involving visual understanding, diagrams, physical layout, spatial reasoning, those are areas where human cognition still vastly outperforms current AI, even the best ones.
Okay. What else?
There's also an active debate about whether the, quote, mild improvements over previous Claude versions fully justify its premium cost for every single user.
Ah, the cost of benefit question.
Right. I mean, if your coding needs aren't at the absolute bleeding edge, maybe the cost isn't quite worth it compared to slightly older or cheaper models.
Hmm.
And you might also recall Anthropic's CEO publicly dismissed open source as a red herring earlier this year.
I do remember that. Caused a bit of a stir.
It did. And that stance drew considerable criticism, particularly because some in the community perceive Anthropic as having, let's say, comparatively weaker infrastructure and optimization compared to some rivals.
Interesting point.
And some argue that this kind of undermines their position when arguing against the rapidly advancing capabilities of open models.
That's a fascinating competitive angle, isn't it? Especially in a market where openness, like we just discussed with OpenAI, is becoming such a significant differentiator. So the key takeaway for our listener here seems to be that Claude 4.1 Opus is this elite specialized tool.
Exactly.
But it also highlights the really different philosophical and business approaches these major companies are taking in the AI race.
Precisely. What stands out for you about Opus is its specialized, top-tier performance for very specific, demanding professional tasks. It's really a showcase of what a highly refined, proprietary model can achieve when it's focused on a particular niche. And that contrasts sharply with the broad accessibility push we just discussed with OpenAI's GPT-OSS.
Right, two very different strategies playing out. Okay, so from highly specialized coding assistance, let's now leap into something that feels like it fundamentally redefines creation itself. Something feeling straight out of science fiction. Google DeepMind's Genie 3.
Genie 3, yes.
This isn't just a language model or an image generator. It's being called a groundbreaking world model. What does that even mean? How does it work?
It's truly revolutionary, I think. Genie 3 is a generative AI system that can create entire interactive, K-able simulations, effectively miniature virtual worlds, just from a simple text prompt.
Just from text.
Yeah. Imagine typing a sentence like, a hero exploring a pixel art dungeon, or maybe a character walking through a snowy forest, and instantly stepping into a dynamic simulated environment where you can actually control a character and interact in real time.
Wow.
DeepMind itself describes it as, effectively, Game Engine 2.0.
Game Engine 2.0.
Yeah, where the sort of data-driven blob of AI weights replaces the traditional complexity of building a game with engines like Unreal Engine 5. It learns the sort of physics and rules of a world from watching existing video data, allowing it to generate new, consistent environments on the fly.
That sounds uncannily like the holodeck from Star Trek, right? Where
Yeah.
you can just materialize and interact with this simulated environment. How real or maybe coherent are these simulations right now?
They're impressively coherent, especially for an AI-generated system. Genie 3 can apparently generate multi-minute, real-time interactive simulations.
Multi-minute, that's quite long.
It is. And rendering visuals at 720p. So the visuals are crisp enough to feel immersive, and you can genuinely explore for several minutes. A major breakthrough here seems to be its World memory for environmental consistency.
World memory. What does that mean?
Well, previous generative models really struggled with maintaining visual fidelity and, coherent physical states over time.
Uh-huh.
Objects might disappear or physics would suddenly break down.
Right, I've seen demos like that.
Genie 3 allows it to sustain these consistent environments for minutes at a time with its, quote, visual memory extending as far back as 1 minute ago.
Okay, so it remembers what things looked like.
Yes, and this is a huge leap from prior versions. For example, Genie 2 wasn't capable of real-time interaction at all. You had to input the entire sequence of moves up front,
Ah, okay. Less interactive.
much less. With Genie 3, you can genuinely look down and see yourself walking within the synthesized environment or explore a simulated pixel art game world in a way that feels surprisingly responsive and continuous.
Okay, here's where it gets really interesting, I think. This sounds like a monumental step towards truly dynamic, AI-generated virtual worlds. What are the broader implications if this technology keeps advancing at this kind of pace?
The progress is truly astounding, isn't it? In just 8 months since Genie 2, the visual fidelity, the pixel counts, they've quadrupled.
Quadrupled in 8 months.
Yeah, making the generated world significantly sharper, more detailed. And crucially, the amount of time you can genuinely interact and explore these worlds has increased tenfold,
Tenfold.
moving from just fleeting glimpses to sustained, pretty immersive experiences.
And yeah, speculation is rife about its potential to revolutionize AAA game development. Imagine rapidly prototyping entire game worlds or transforming VR experiences, accelerating metaverse applications.
It feels huge.
And many believe it bridges a critical gap towards artificial general intelligence, AGI, by granting models a form of imagination or visual spatial reasoning that feels closer to human cognition. It's about AI not just understanding concepts, but actually creating and simulating entire realities. It's definitely easy to get swept away by the futuristic possibilities of Genie 3. But, for all its groundbreaking advancements, what are the current limitations? What keeps it from being a fully fledged production-ready system today?
Right, got to stay grounded. While it is groundbreaking, it apparently still has systematic physics failures,
Systematic physics failures.
particularly with things like rigid body interactions and combinatorial tasks. So objects might sometimes pass through each other or behave unrealistically in complex scenarios.
Okay, so the physics aren't perfect yet.
Not yet.
Yeah.
It also has limited multi-agent social interaction support, so you won't be interacting with complex AI characters or societies within these worlds just yet.
Right, just the player, mostly.
Yeah, and it has constrained action spaces, meaning the types of interactions you can actually perform are still limited. It currently lacks advanced game logic or complex instruction following. So yeah, it's far from a production-grade game engine that could run a complete, polished game right now.
That makes sense.
And there are also significant questions about the sheer compute demands. How soon could models generating this kind of high-resolution, high-frame-rate content run outside of specialized data centers? Broader accessibility is still a challenge.
So while that holodeck dream feels closer, it's definitely not quite ready for prime time. And it makes you wonder, are these systematic physics failures just temporary hurdles, or do they represent a deeper challenge for AI to truly grasp our physical reality? What's the core takeaway for our listener from this glimpse into AI-generated worlds?
Yeah, that's the million-dollar question, isn't it?
Yeah.
I think it highlights that while AI can generate incredible visuals and even imagine these worlds, truly robust physical simulation or complex social AI is just orders of magnitude harder than generating coherent text.
It's a different level of complexity.
Completely.
Yeah.
It's really where the rubber meets the road for AGI, I think. And these physics failures are a stark reminder of how far we still have to go, even with this remarkable progress. So for you, the listener, this is a tantalizing glimpse into the future of interactive media and simulations. It showcases AI's burgeoning ability to create and imagine worlds.
A preview of what's coming.
Exactly.
No.
Even if the practical applications for fully autonomous game creation are still some way off, it's like a preview of a future where you might just describe a game you want to play and the AI builds it for you.
What an incredible snapshot of where AI is headed. This past week just gave us so much to think about, from OpenAI's surprising strategic move into open source to Anthropic's mastery of those specialized coding tasks, and then DeepMind's fantastical, almost unbelievable world-building capabilities with Genie 3.
Indeed. This week really highlights the diverse and incredibly rapid evolution across different facets of AI. You've got making powerful reasoning accessible right there on your laptop,
Right.
creating elite tools for the most demanding professionals,
Yep.
and literally generating interactive new realities that start to blur the line between computation and imagination. It's a powerful reminder that AI is developing on multiple fronts all at once.
The landscape is changing so incredibly fast. It's truly thrilling to watch. And it forces us to constantly reevaluate what we thought AI was really capable of. And I think it raises a pretty powerful question for all of us.
Which is, if these systems can now effectively imagine entire worlds or embody complex reasoning right there on our personal devices, what fundamental human-like capabilities will AI unlock next? And, maybe just as importantly, how quickly will we adapt to interacting with these rapidly evolving digital intelligences?
Exactly. Something for you to mull over until our next deep dive. Thanks for joining us.